So the journey and you get this. I'll feel about it.
Yeah, that's it. No. Okay. Excellent. Okay. I could do extend. Okay. That's not gonna work. Okay. Welcome everybody. Hello. Welcome everybody. Oh, so, we should probably close the doors and start. It's already 350, 352. First of all, this is 6 low, just in case you're in the wrong place. Make sure this is what you want to be. We have a minute taker. Thank you, Dominique. There you go. And I believe we have a Jabber scribe as well. Thomas, thank you. So I think we're all set. Make sure you see the note well. This is just to see if you're awake. Actually, you may have noticed this is not the very latest and greatest note well. That doesn't matter. You have to be aware of the very latest and greatest note well. It was recently updated. I didn't actually manage to do it on time, but it doesn't matter. You have to be aware of the very latest, and you can always get that on the printed agendas and on the IETF webpage, etc. So make sure you understand this. Something you don't agree with it, then you should leave. This is our agenda for today. It looks a little packed, but I think we should have, at least in theory, a little bit of time left at the end, which is good because we have sort of a discussion planned for the very end. So if we have any extra time, I'm sure we'll be able to use it. But basically, we're going to have an update to 6 Low Pen and D, which is actually a collection of about 3 documents with Pascal. And then Yongun will give us an update on the applicability and use cases for 6 Low. We have Charlie on packet expiration, transmission of IPv6 packets over PLC. And then we have a new proposal for body area networks, 15.6, by Sajad. And then at the end, we have Pascal again, and with the chairs, we're going to moderate a session. In total, there will be like 40 minutes. So Pascal will start with some requirements, and then we're going to have more like an open discussion, hopefully with some folks from transport as well. Summarizing status since Chicago, we have 3 new RFCs. So deck ULE now became RFC 8105. The low back document now is 8163. And not that it was a working group document officially, but we definitely benefit from it. This is draft keeping in on 82.15 IE became 8137. And as we had announced in Chicago, we actually went forward and carried through and dropped the mesh link establishment effort that we were undertaking, partly or quite in large part due to interest from Jupyter Mesh and Zigbee NAND. Since they no longer needed it and we didn't get the required update, then we dropped it, and everybody was fine with that. Status of documents since Chicago, we have, well, backbone router, you'll see an update on that. That's still ongoing. NFC, we will see an update by Singapore. So we don't have one right now, but by Singapore incorporating more comments, etc. APND is also part of the quote-unquote 6775 update, which Pascal will tell us about a little bit more. The other interesting one was Bluetooth LE Mesh. We could have had an update this time around, but the authors very wisely decided that it probably made sense to wait for implementation experience. That's always a very good reason to wait for a little bit more. So implementation experience, we should have maybe something by Singapore, hopefully, and the applicability and use case, we'll see an update now. And of course, 6775 update itself, the main document there was updated with working group comments. After that, we actually issued a working group last call, which finished about a week ago. And there were no comments during that period, but I understand some people are still thinking of sending comments in. So, but it looks reasonable. And that's pretty much it for status. So, unless anybody has any agenda bashing, we can go forward. Pascal? Let's see. I'm not going to insert anything here, so I just say next and I'll. Yeah, keep the laser.
Okay, so this is Pascal Thubert from Cisco. So I will talk to you about our suite of drafts, which basically stands from the RFC 6775 update and then goes all the way to the backbone router and the address protection drafts. Next slide, please. So we have extracted the RFC 6775 draft from the backbone router draft. They were both in the same place initially. And so we have extracted what really updates the RFC versus what is the new proxy operation. So basically, the RFC 6775 update can be seen as a layer 3 association process, whereas the backbone router is like a proxy operation. What does a router do to act as a layer 3 proxy for neighbor discovery? Next slide, please. So status of the draft, a refresher was published late June. So there's a number of cleanup activities which took place. There was this big review that Samhita published on the mailing list, and we acted on that. We removed the text which explained how you can avoid sending both REPL DAOs and DARDAC, and this being decision being made on the basis that this should be a separate document which really focuses on savings you can make when you get both on the same network, but this document is exclusively about ND. So the references to REPL are gone. We'll have to write them somewhere else. We might have been too efficient in doing this, because one, so nice way of saying, yeah, okay. Well, point is, there is one important thing which is the operation of the sequence counter and how it wraps, how it's initialized, how it's reinitialized, etc. When you reboot. And all this text was actually a reference to the path sequence in RFC 6550. You do the same as this. As we remove the references to 6550, now we don't have any more operation of this sequence counter. So we are missing that text, and we have to decide how we reinsert it, either as a reference to 6550 or we copy the text so our RFC is self-contained. But it's a clear goal that it obeys the exact same rules, because you need to be able to use one or the other, but not having to send two messages in a repo fabric. We have added 2 versions ago the recommendation, Carsten, to use 7400 to expose the capability to do this new draft. Now we can live without it, but it's better, it's clearer to announce that through new bits in that draft that this capability is supported. There was also a need for the address protection draft to provide an additional status code, which means that which basically returns that the proof that was given for the security token is not accepted. And so this status is provided here, but the action on the status is in the APND draft. And we separated the privacy discussion from the security consideration. So we have two now, those two separated. The security consideration is the usual security thing, and all the text which says, oh, by the way, we don't tell you, oh, you build an address, we place no constraint on what you do, but if you do it, please make sure you follow the privacy recommendations. This is now its own section. By the way, there is at least one implementation. I've seen 2. I don't know if the second one is complete. The document was ready for last call. It was actually last call. I thought I had fixed that slide, so I'm confused, but maybe I wrote it on a different slide.
Yeah, finished last call a week ago.
We finished last call. There were not so many comments. Some of them I received directly. So I asked the author to publish them on the mailing list. It was not done, so please consider that it's not completely complete until those comments are published. And there we go for this slide. Next slide, please. Oh, no, it's not the right slides.
Oh.
Because I checked on the site and they were good. So that's why I was surprised that this slide was incorrect.
We have a separate one for backbone router.
Yeah.
This one.
Yes, everything separate. You get the update, you get
This?
backbone router. Yes, this one is correct. That's the second draft, but I was supposed to be presenting 6550 first. Oh, this slide is correct anyway. No, that's the old one. There used to be three decks in one, and Samit asked me to send them separately. So the old deck with everything in it is deprecated.
Yeah, I think I got your 3.
Yes, and
new
these are the
ones.
3s that I need. So this slide won't always be discovered to that.
That is one of the 3. This is the second one of the 3, and this is the third one of the 3.
So I agree with the second. But there's only one slide, and it's correct on the website. There's only one slide in each of the backbone router and the interface.
So what is, I don't know, these are the 3 I have with me. These are the 3 you're going, and the extension backbone routers, these are the new ones.
Yes, these are the new ones. Can you open the one?
That's the one that's open here, so it doesn't do anything because it's already open. And this one.
No, this is real. Okay.
Can you present with this, Pascal, or do you want to swap out?
I can talk anyway.
Yeah.
No, but swap out, Pascal. I can take the next person on the agenda while you figure this out. You want to do that?
That would be nice.
Okay.
Yeah.
Sure.
Okay.
Resend the slides to Gabe.
I can also bring that up here.
Why don't you make sure they're there?
Oh, I can just, if you want me to
Yeah.
connect this to
Yeah.
my laptop, then also.
Yeah, just connect your laptop. Oh, not this one, this one. Do you have a
Yeah.
VGA
This works for me.
directly?
This works for me.
Okay. There you go.
So guys, What kills me is that on the very side. So we are on the first. So there we go. You see, there are the PowerPoint and there are the PDFs. Okay.
Just start, Pascal. It's good. Like I'll announce for them. Okay.
Yeah.
So for the people remote, including Samita, like Pascal is just switching slides. Getting all
Yeah,
the
can you guys hear me?
Yeah.
Yep.
Okay, great.
Okay, so this is really the slide down. Okay, so just to give a little background about the whole work is we are at the crossroad of wireless and IPv6, and on both sides there were expectations, requirements that were thrown over the fence on what basically a standard group expected from the other. For instance, IPv6 has designed solicited multicast with these requirements that there would be 2 to the power of 24 multicast groups to make it perfectly efficient. But on the other hand, those groups were never, the capability to have this number of multicast group was never present on the IEEE side, meaning that it has always been broadcasted as opposed to multicasted. That's never prevented ND to work, but that kind of creates limit to the applicability of ND to experimentally 10,000, the order of 10,000 nodes, right? Which this limitation really comes from the fact that the multicast is broadcasted. Now, on wireless, it's stringently different. Now, in a general manner, ND requires a very reliable multicast or broadcast operation. Even if it's a broadcast, it needs to be very reliable because that's how we discover address duplication. And as it goes, we all know that due to some laws of physics, sadly, the wireless will never provide that. Cheap and reliable multicast is not something that radio can provide. So certainly 4862 cannot operate as designed on radios, which boils down to the fact that if it appears to work, it's mostly because the entropy of IPv6 addresses makes it so that the collision is very rare, not because IPv6 operates as designed. Okay, so this is basically the expectation from the IETF and what the IEEE should have or should be doing, but that was never present on the IEEE side. Now, the same effect exists on the other side as well. There are those expectations that the IEEE has on IETF, which were never really there. In particular, in .11, you read that Wi-Fi recommends that a proxy operation is performed on the IP for ND and ARP. As it goes, we have never specified this operation. And so we have resorted to proprietary implementations to decide how exactly a proxy would operate in that particular context. And the one thing which certainly does not exist and cannot be done without a standard is the equivalent of the association. Because what those implementations do is that they snoop ND and the HCP. Eventually, they resort to traffic if nothing else works. And based on that, they discover that a certain address is present on a certain AP, and that's the way all this proxy operation is kicked off. Basically, we now use RFC 6775 update as the layer 3 association process, whereas the backbone router is the proxy ND operation process. So we are finally bridging the gap between IEEE and IETF and providing the missing link, which really enables a proper operation of NDP over radios. Next slide, please. So this I already presented. Next, I think. This I already said. Okay, and this one has the correct dates in it. So like I was saying, we have addressed, we are there? Go back, yeah. So now this is what I was trying to say on the previous slide, which is this is the pointer to the last long review that we had on this document. And so we had this privacy discussion. We were a bit too efficient in removing some text about the TID. We have removed the text that enables the DAO, sorry for the typo, to refresh the DAR state. And we passed working group last call. Okay, so next slide, please. So like I said, I get some private commands. We'll address them, but I asked the author to copy to the list, otherwise I'll forward. Like I just said, we probably need to point again on 6550 or to copy the text which describe how the sequence counter is initiated, the lollipop thing and all that sort of thing. And question for the chairs is, do we have enough review to call it victory, or do we need more workgroup time?
Gabriel Montenegro, on the how to restore the information that was taken out, I would much rather, I would vote for having a self-contained document, because if you have a pointer there for something that would end up being normative to Ripple, and you are implementing something that has nothing to do with Ripple, because supposedly this could be a more general facility, you don't want Ripple to be normative.
Great.
So you want the document to be self-contained. So that would be mine.
So I will ask the author of that text in Ripple if he can give me the text. Hey, can you give the text? Yes. Okay, that's done. I'll do it.
Okay.
Rahul Jadhav from Huawei. The update allows the proxy to register to a proxy-based registration to 6 BBR is what I understand, right? So extended ARO option allows a proxy-based registration.
A registration to the proxy
on behalf of the target.
Okay, so now the word proxy appears twice. First is for instance, a Wi-Fi devices could register to the AP acting as a layer 3 router to get the proxy and the operation. So that's the first occurrence of the word proxy. There is a second occurrence of the word proxy. I think you're talking about the second one, whereby the root of the Ripple DODAG can proxy the registration to the proxy on behalf of all the nodes which it learns through Ripple and maintains through Ripple. So that's why it's so important that this TID operation is aligned to the operation in Ripple. Because basically, in normal runtime, you won't see the DARDAC periodically. You will just see the DAO periodically. But the TID inside the DAO that the root receives will allow the root to maintain the state on behalf of the registered node.
Target node, right?
Yes. So that's why actually one of the big changes that we have in this document versus 6775 is that we register the target as opposed to the source, because the root of the Ripple DODAG is the source of the packet. But what's being registered is the target. Actually, it's, in my mind, I mean, at least mine, it's kind of quite consistent with the usual use of a target. So I'm pretty happy with that change.
So, the next question from me would be, is it even possible from 6 BBR to deregister on behalf of the target?
To what?
To deregister. Like we have the proxy registration now.
Yeah, sure. If you get a no-path DAO. No, I don't think the spec allows you to do that. I'm sorry, but I have some text on that. I just don't remember what I wrote.
The reason why it gets complicated is because of the TID, addition of the TID. Now it has an associated state information which it has to maintain. So,
which has a lifetime, but we have to think it through whether it would be a good idea that a DAO with a lifetime 0, a no path DAO, creates a deregistration or not. And out of my mind right now, I don't remember the arguments. There are some, and they are in the draft. I think I discussed that case, but I don't remember. Can we take that to the mailing list?
Sure. Yeah, thank you.
So Pascal, like, do you think that's gonna result in changes in the draft, or?
I don't know yet. Can we integrate that as a workgroup question? The realistic question?
This is part of working with last call. So
that
and the forthcoming comments that you indicated. Yes.
So Raul, let's have this discussion on mailing. Let's just clarify. I think there is text on that because I kind of remember writing it. I just don't remember what the arguments was. So I don't remember what the conclusion is. If you disagree with what the text that's in the document, then please raise a mail on the mailing list and we'll sort it out.
Pascal, this is Samita. Pascal.
Go ahead.
So I was referring to Pascal's question on whether we should extend the working group last call. May I suggest that maybe we could, after he publishes the next revision, maybe we could have a short extension for 1 week for people to review. Does that make sense? Maybe Gabe and Suresh, what do you think?
Would that be, Samita, clarifying question, would that be, dependent on the amount of changes that are put there, right? Because I was asking to get, my question was not spelled correctly. My question was, do we think we have enough review during this work group last call to call it victory? It was not about the comments resolution.
That's how I understood it. And I mean, I'm okay with waiting a little bit more because we know there are comments forthcoming. It would be a shame to not allow them to come in. I mean, it's just a few more. So yeah, let's just wait for those comments to come in.
Okay.
And then we'll deal with whatever happens, just like any other working group last call. If there are too many changes, we'll do another working group last call.
Sounds good.
You probably have the 2 other slides right next to it.
This is, so you're going to the backbone router, okay, this one. Okay. Yeah.
Go for it. So like I said, the RC 6772 update extends the operation of the update from a DAD operation to a registration operation for services such as ProxyND. In the future, we may decide to use it to register other things, but at this moment, it's ProxyND. The backbone router is the ProxyND operation to which the update enables the registration to. Next slide. Okay, so actually I just published a refresh because the document was reaching timeout. We have an implementation. It has been demonstrated several times at the IETF, including at the 6-dish plug test with a client by Thomas, by the way. Certainly, we could use more implementation. Certainly, I would love to see more interop. In particular, I would love to see a open source backbone router implementation to test the interoperation between 2 backbone routers on the backbone. Because what really happens is when you've got a mobile device, Wi-Fi or 6LoWPAN, that moves from one 6 BBR to another 6 BBR. So it moves from Ripple DAG to Ripple DAG, and there are different 6 LBR. Now, the 2 6 LBR need to agree on where the device is. And that's part of the spec does, right? Enabling movement. I have not tested that with another implementation, certainly, because I only have mine. So I would love to see another implementation and play with it. But that's where we are. I also asked IEEE, in particular .11 experts, to review those 2 specs. So this is happening. We'll see what pops up on the mailing list. My goal being, this was kind of reviewed for the 15.4 world. I would like to have an assessment of the .11 world. Just to, so if they see, if you change those 3 bytes, or these 2 words, this would be applicable to Wi-Fi. Sadly, it's not like that. That would be bad. So I've asked that. But otherwise, for I'm concerned, I mean, it seems that this is ready for work last call. It's been very stable. Any reaction there?
Shoot.
Nobody pops up, yes, I'm doing an open source implementation? No? 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 Okay. Yes, you were. I know. I really hoped. Almost good enough. Okay. Well, we are done for that one, I guess. And then there is the address protection.
This one here.
Okay. And Besat, I see you're in the room, so please jump in if there's anything you want to add to what I'm saying. So certainly, this is the 3rd piece of our story. This is how we perform source address validation, which is savvy. because we have this state in the 6 LBR, we can validate, including a crypto state. We can validate that the user of an address is the one which registered it in the first place. We can validate that when an address moved, the new place, well, the new device which claims the address at the new place is the same as the old device, and we can validate that with some cryptographic exchange, proof of ownership, basically, of a token which was given in the first registration. That's pretty much what it is. So we kind of revamped it quite a bit, to be honest. It's editorial, but we have removed a lot of extraneous text in appendix. So there is a lot less normative text, which normally would help later in the process. We have added this section about updating RC 6775. And we claim that we are ready for a review by, at least a first review by Security Directorate, for which the chairs basically called and asked Tero Kvinen, who has been helping us a lot in many security activities, and who's an expert of 15.4 security. Yeah, well, summer was not the best time, but we expect that early after summer we'll get the feedback from Tero. That's basically where we are. Again, any question? No.
I think we have to get moving.
What?
We have to get moving because it actually took a lot of time. Okay. So next on the agenda, the Yongun with the applicability and use case. Hopefully I have the right slides this time.
Okay, hi, my name is Yonggun Hong. So I present the 6-row applicability and use cases. Okay, this is the history. We discussed from this issue from IETF 89 meeting 3 years ago. So we present the first individual draft and IETF 94 meeting, and we the working group adoption was done in the last year. So this is the second revision. So I would like to focus on the goal of this document. This document, the goal is to help 6-row pen stack adaptation by layer 2 constraint technology and help a newcomer understand how 6-row pen stack can be applicable in practice. So useful new adapter of IoT at IETF. So in this revision, we try to include some practical 6-row technology. So that is the Byte mesh and Wyson. So the update based on the last IETF meeting, so we got several comments. So the goal is to make this document more shortened and clean and focus on applicability. So we specify 6-row linklet technology in the cell. So we make the LTMTC is the example of the potential 6-row L2 candidate. And as I said, that we include we include two practical 6-row deployment scenario, that is Wyson and Byte mesh. And we add a new section of guideline for 6-row pen adaptation. And we move 6-row use case example to appendix because we are focusing on the applicability. So the some text for use case is moved to appendix. So we add some additional editorial comment, and Samira helped us much. So she is added, so one of the author of this draft. So in this document, we have the 7 6-row link-array technology. That is G-Wave, BLE, and DECT and MSTP, NFC, and PLC, and IEEE 808.15.echo. So in this link-array technology, the PLC is under the individual draft. So I hope so. This technology and the draft for regarding this technology should be some of the working group document in this working group. And we mark the LTMTC as the potential candidate because we survey and we solicitate the practical use of the 6-row, but unfortunately, for regarding LTMTC, there are no practical 6-row deployment scenario. So that's the reason we mark as the potential candidate. Yeah, this is the comparison across the 6-row link-layer technology. So there are 7 technology, and we want to compare their uses and their technology and subnet and mobility requirement and security requirement and buffering requirement, latency queue requirement, data rate, and there are some related RFC draft. So as you can see, there are some common point, and there are some different points. So if you look at this table, you can analyze or you can evaluate some link-layer technology for your target services. So that's the reason we made this comparison table. Yeah, and we add the new section that is the guideline for adopting IPv6 stack. So it target candidate for new constrained L2 technology that consider running modified 6-row PAN stack. So we must consider that item, that is address model, MTU consideration, HOS3 routing, address assignment, header compression, security and encryption, and additional processing. So until now, we have the 7 link-layer technology, but in future, maybe new 6-row link-layer technology could be made. So in this case, we should consider their technology for these items. Yeah, so we add some practical 6-row deployment scenario that is YSON. So this text was helped by the Paul Duffy. He is working in the YSON Alliance. So you can see the YSON technology is based on this technology, and among them, YSON Field Area Network (FAN) technology. It covers some the related network technology. So we found that YSON uses of 6-row stack is the advanced metering infrastructure AMI and distribution automation TA. So it is some interesting point that 6-row technology is really used in the real world. And another 6-row deployment scenario is Python mesh. So Python mesh specification is based on this technology, and the Python mesh in smart grid is using the 6-row network layer. So this text was provided by Michael Bellitis and Dash Shubier, and so thanks to their support for this document. Okay, could you next please? So and we had some the design space dimension for 6-row use cases. For example, deployment, bootstrapping, topology, L3 or L2, and something blah blah. So originally we describe and we write some the specific design space dimension for each 6-row technology, but there are lots of context. So we delete many parts, and we would like to focus on the design space in here. And 6 use case. As I said that in the main part, only one use case of BLE, that is the smartphone-based interaction with the constrained devices, and the other use cases, for example, G-Wave, back to BLE, and MSTP, and next page, please. Yeah, NFC, PLC, IEEE 8.15.echo, that use case is moved to appendix. So we make this draft more shortened and more clear to how to understand what's the goal of this draft. So that's all. So thanks.
Carrie Lynn, first of all, thanks for pulling all this together. I think it's a very useful survey of the field. I guess my question to you is, one of those things on the list is not like the others, which is MSTP, which is wired, and everything else is wireless. Have you thought about doing some sort of, I don't know, I'm just wondering if there's some sort of a figure of merit that might be based on, good put per, times distance times price or something like that. I mean, how would somebody, choose a wired data link over wireless based on reading, your document?
Yes, the good question. So actually, we don't consider the differences between wire and wireless. So except MSTP, other technologies are based on the wireless, right? You can see. So
There's PLC too, right?
sorry.
PLC.
Also PLC. So PLC is not the working group document. Yes. So MSTP and PLC is the wire, and other technology is wireless. So okay. So currently we don't have text that reflect your question and comment. So I'm thinking, and I tried to how to reflect. So you can help us. Okay. Thank you.
Pascal Tubert, I'm just reacting to what Kerry said, and there is some feedback from the real world in the metering business where they will tell you that for large-scale metering, there is not one link layer solution that fits all situations. For instance, if you have building, if you get line of sight, if you don't have line of sight, if you have concrete, etc. And the return from implementation and deployment that I got is that having a layer 3 routing technique, which allows you to actually use multiple sorts of link, and maybe you deploy both and you see what works, is a lot better than deploying only one and send a technician back later because it does not. Right. So that's really where the power of routing and using Ripple in this kind of use cases is so visible, because you will actually use both wires and wireless.
Okay, thank you. So any other question, comment? So you can see this document includes some of the barriers in clear technology. So I'm not expert of that area. So we need some other expert to review and give some the practical information of the 6-row linked technology uses in the real world. So I'm also asking, and the Kerry says that he gave us, and the other person, I'm waiting your input of this document.
Yeah, so thank you. Charlie?
Okay, well, hello, I'm Charlie Perkins, and do I just say when it's time to change slides? Or
Yeah.
Okay, yeah, I guess it's time. So just a quick overview. We've been working on this draft to specify the delivery deadline times for packets in a 6-low-pan network, and currently we have packet delivery deadline time, and then also you can put in the time at which the packet was first sent. And with this information, you can make decisions about whether to drop the packet because it's not going to make the deadline. And you can also make determinations about how long it's been in transit. So it's a pretty simple idea. And it also assumes basically that you have a time synchronized network so that you can have a consistent idea of what time it is. So that's sort of an underlying assumption. And given that you have different networks that are still basically synchronized in time, even if they have different ideas of what the current time is, you could still do transmission between those networks. Next slide, please. So after the last IETF, there was discussion about including ASN as a time unit, and so that seemed like the right thing to do. And so we put that in. There was also some discussion about how to handle the reserve field. We didn't do anything about that except just to say that it's reserved. But other than that, the draft has not been changed very much. But one sort of pervasive change was to the draft currently is, the name of the draft is expiration time, but I think deadline is much more accurate description of what is provided. So in the text of the draft, it basically usually says deadline or delivery deadline or something along those lines, but the name of the draft has not been changed. So, I mean, except to say it's -04. So next slide, please. Here's a quick look at the format for the extension, and it's see, well, basically there's O means that the origination time is present. D says how you can handle dropping the packet if it's, for instance, you may allow for this information to be transmitted even if the deadline is passed, if the D flag is set to be 0. Question?
Yes, Pascal Hubert. Charlie, there seems to be, I'm still very supportive of this work, right? Be very clear. There seems to be this assumption that you know how fast it takes to get there, and that the routers in the middle know if this packet is late or not late, or do you just want to drop the packet when it's too late, but having no clue at all if you can make it? Because it seems to me that basically you should drop the packet as soon as you know you cannot make it, not go all the way till deadline.
Yes.
But that seems to imply that you know how long it takes to make it, and my comment is pretty much the same I did last time. Is, for instance, if the root schedules the transmission all the way using non-storing mode all the way, it would probably be able to compute also the various hops deadlines, and so use that recursively or use that along all the hops, so that each hop would know how much time it has to forward this packet just to respect the schedule. And if you end up doing that, then you have a source routing sorted version of TSN, basically.
Well, you kind of do that with TTL, right? I mean, if you want to say that this packet can't survive more than 5 hops, and
I'm not talking about hops. I'm saying, oh, if the root schedules this path with this source routing information, and it knows the packet must make it by that time, it can also say, oh, first hop it should make it by that time, second hop by that time, all expressed in ASN. So you're really able to give the network what is your reference forwarding expectation.
You know, I can somehow imagine a network where you'd like to have that close control of granularity of planning, but I don't know how to do it. And I think that this is going to probably get a huge majority of the applications. And, you know, as you say, let's say that you have an intermediate point where you're 1 microsecond away from the deadline. Well, you might want to drop it anyway. This is simple enough and useful enough that I'd hesitate to volunteer for additional complication. Okay, so you can go out there and get the implementation. It's been merged in with OpenWSN. It was presented also at 6TISH by Elijah, and we view them as a natural customer for this sort of feature. And the implementation has a EDF, or earliest deadline first policy, which I think is one of the most basic kind deadline policies you might want to use. Question?
Carrie Lynn,
Yes.
I'm just wondering if you've got any information on whether the dominant delay is queuing delay or transmission delay, or does this vary by technology? I'm thinking back to Pascal's question or response. It seems to me that in a mesh network, for example, it'd be very difficult to predict that all of the hops have the same cost, for example, because it seems like as you get closer to the edge, those nodes are doing more routing on behalf of other nodes below them, so that potentially there's more traffic going through those nodes.
Yeah, I think, if you want to take a look at sort of measuring the distribution of delay times through the router and then slice it up between queuing delay time and other effects, that's a pretty good paper. And as far as I know, depending on which network, different effects are dominant. I mean, some it's if your network is congested, boom, that's it. And I'm not sure whether you want to count delay because of interference versus queuing delay on the router. Those are two different kind of things. So I'm going to sort of maintain my blissful ignorance here and just say, we just want to say what the deadline is and let it go at that.
Go ahead.
Thomas, Carrie, I want to answer. I think it depends on the technology. From the OpenWSN stuff that we did in 6-dish networks, the delay time is mostly queuing. You wait for your slot.
Yeah, that's my yes. I actually had a second question, and that is, how closely do the clocks have to be synchronized? Do you is it just within some epsilon? In other words, can they sort of oscillate within some some epsilon?
Well, what if I told you that we measured experimentally that the clocks have to be within 1% of the deadline time? That would be a total lie, but you could make any sort. I mean, you can decide. You could get into the question of how hard is the deadline, and that would go back to this D bit that we talked about, whether you're allowed to pass it along or not. And this is a valid point of discussion. But on the other hand, maybe it's a better idea to just put it out there and see what's really needed.
Maybe we can just catch up for like 2 minutes tonight if you're going to the social. I want to tell you about a project that
Oh,
worked on
sounds
years ago.
great. And I'll
Okay.
be at the social if you
Okay,
want
cool.
to chat.
So, Charlie,
Hi, Samita.
just a quick, hi, Charlie. A quick question on the time synchronization. So I understand that it works on 6-dish. But do you have any recommendation of a time synchronization protocol, or how what time synchronization mechanism should be used for this draft?
No, we don't have any additional implementation. Let me see. Now, I shouldn't say that because, I didn't actually do this implementation. It was done by Elijah and folks. So presumably, I mean, if they're running on a normal platform, you can have a time synchronization protocol running. But I don't have any additional information about the specifics of that.
I think it would be good to have some sort of either boundaries that I think Kerry was mentioning, or some sort of information of time synchronization, because it seems like this is a dependency for this for your draft. So some recommendation on time synchronization or reference would be good.
Okay, that's a good point. How about if I compose a message to the mailing list and we have discussion and we can insert a description about that? I'm looking at you sideways. So,
Thanks.
Do we have another minute? Yeah. So Thomas, time synchronization, I can answer exactly for this implementation. In this implementation, it's in the order of across the network around 100 microseconds. In commercial it's around 10-15 microseconds across a 100 node network. But But this doesn't have anything to do with this draft, right?
Not
This draft
really.
just says timestamp in, timestamp out, and whether you're well synchronized or not well synchronized, it doesn't affect at all this draft. This draft just timestamps. So I think, you know, how the network is synchronized doesn't really matter. It's to the application to say, okay, I just received a packet which has this timestamp. What do I make out of it? I know what's running in my network. I know how much I can trust it. But this draft will carry it regardless, right? It's independent.
Right. So what I understand is, just to make a dumb example, let's say you send out the deadline thing here and say, I want to have a deadline of 1 microsecond from now, and you're not going to really get very far. So we could insert some language in the draft that says, well, you know, the precision of your deadline time has to be affected by the precision of your time synchronization, but that won't change the format of the packet.
Yeah, agreed.
Yeah, but you know, if the time synchronization precision is not very accurate, then time out minus time in minus time out may not be very correct. So if you specify some, you know, range of time synchronization precision, that would be good enough, I believe. But I think we can probably discuss on the mailing list.
Well, I know if you see something on the mailing list, please comment. All right.
Sure.
Gabriel.
So I had a question, trying to understand the semantics of this thing. So looking at the D bit, you turn it on, then you're supposed to throw away the packet if it's beyond the deadline, correct? But the operative word there was should. So do applications know if they have to rely on this, if they can maybe rely on it? Is it meant to be just to get rid of extraneous traffic on a best effort basis? I mean, what kind of semantics are applications expecting? Or are there going to be issues if there are duplicates, for example, because somebody did not obey that should, as they're, you know, open to do? If it's a should, it's not a must.
Would you recommend that we change should to must?
No, I'm asking because I don't know how it's used. So I don't know what applications expect. There was a question about that. If applications expect very clear, crisp semantics, then I guess a must is probably a better choice. But I don't know what the applications do with these things.
Okay.
If it's meant to just get rid of extraneous traffic, that should is fine.
Okay. I don't know how to answer that, but I mean, we could ask 6TiSCH folks. They might know.
So Thomas, I'm not answering 6TiSCH. I'm just thinking out loud about applications. If you send a packet with one of these headers in there and you set the debit for drop after deadline, I mean, you expect it to drop, right?
So we should make it a must instead of a should.
Well, if it's a should, then I set the bit and what happens? So either I don't set it and it just carries on, or I set it and it must be dropped. So I would say that to must, otherwise I don't see.
I'm okay with must. Okay, next slide. So
They implement it.
we would like to request working group adoption of this draft. I think it's obviously has a purpose. Pascal, do you have a question?
I'm bugged a little bit. This is I always forget the name, but this is a header that you can ignore, right? So how comes you can expect a must operation on something you can ignore?
I'm sorry.
If you don't ignore it, then you must, then you must be able to.
Well, maybe.
Called conditionally mandatory.
Yeah, Suresh Krishnan. So I don't really see how that can be a must, like, or a serious must, right? Because it's optional to process, right? So if you put it in, you cannot expect it to be enforced. So this is like hop by hop options in V6, right? You can say like, if you don't understand this, drop the packet, right? But like there's another RFC or RFC2B which says that, oh, if you don't want to process hop by hop options, don't do them, right? So like you're in a very, very similar boat, like, because you can say must if you want, right? That's okay with me. But the sender still cannot expect, if you set the debit, that the packet will actually get dropped because somebody won't understand this like deadline option, right?
Okay, can you say a little bit more about why someone would not understand deadline option?
So let's say somebody doesn't implement this draft on the path.
Does not implement it?
No.
Okay.
Not at all, right?
Right.
So, and you said the debit, do you expect it to be dropped or not? Right? Like, I would say no.
Can you rely on the fact that it will be?
Right. You cannot, right? You cannot. So like, you can put the must in or a should in, but the thinking needs to be like, you cannot depend on this happening. This is still best effort because you don't know who's on the path who can actually recognize this, right? Because what you're saying is like I think Kerry said it best, right? If you understand this, like you must drop it. That's different from expecting it to be dropped. I think that was Gabe's question, right? Like, how do you expect it to be honored, right? Okay.
Yes. Well, Pascal, again, you know, Charlie, in Formula, there was this discard eligible bit. If for those who were born that day, there was a DE bit in the DRCI. And what that would say is if you have those 5 packets in front of you and you've got time to transmit 3. Well, if 2 of them have the DE bit, then the choice is clear. You transmit the 3 others. So basically, this looks like a DE bit with a time bomb on it. That's really what it is. I mean, before that time, treat it as a normal packet. After that time, if you really need to discard something, then discard this one preferably. That's a behavior that can be enforced by those who, but the behavior that you cannot get is, let me make an application that is by design is certain that this packet will not be delivered beyond that time.
But
Because unless you've got this thing implemented throughout, then this application will be broken.
Okay, so this is, that you're discussing the end-to-end behavior, and part of the value of this is in the intermediate nodes. And if they,
No, it is.
right. So if they have to, for instance, do some preemption or anything like that, they might preferentially.
That's what
send a
DE bit is
packet
all
that-
about in Formula, right?
Right.
Discard this one preferably, because the application knows that it will lose a lot of value, or it has a lot less value than this other packet. So if you get those 2, this one has DE bit, this one does not, discard the discard eligible bit.
Right.
Well, same thing. After that time, this one becomes preferably, you inform red that it should not be so random after all.
Right. I think, Charlie, the point that I was making, at least I think like most of us are making, is that the must doesn't give you much more than the should. That's it. Like everything else, what you said is right.
There have been entire hours spent on must versus should. And one argument is that people don't care about should. And I don't believe that argument. But anyway, please.
Peter van der Stok. If I want deadlines be done.
Peter, closer to the mic.
Peter van der Stok. Okay, sorry. If I make a network on which I want real time to be executed, I make sure that this draft is there in all the nodes. Yes, and then I expect a must.
Okay.
Very good. Yeah.
So can I say that we should discuss this in the mailing list, and then we'll just do whatever people believe? Okay. So
as JavaScribe, somebody is pointing out that we're 20 minutes late.
Oh, okay. So
okay.
maybe,
So please adopt our draft.
yeah. So I'm not sure we're ready yet to go for call for adoptions, but let's definitely continue the discussions about how applications work with this, that sort of thing, a little bit more, and maybe go for call for adoption after that, depending on how the interactions go.
Great.
At this point, it seems a little bit like we need to discuss a bit more. Thank you.
Oops, wrong one.
So next is PLC networks.
Okay, hello. This is Jian Changho, and today my topic is transmission of IPv6 packets over PLC networks. So this work was done by me together with Donggen and Xiaojun, and currently it's version 1. And today we would like to call for adoption. Okay, next page. So what is PLC? PLC refers to power line communication. This technology uses the electric power lines for indoor and outdoor communications, and PLC has been widely applied to support advanced metering infrastructure. So the figure below is a simple example showing that the smart meters transmit data to a concentrator directly through the electric power lines. Okay, next page. So I presented this draft last time in Chicago and have received comments from Samita, Stefano, and Sari. And based on their comments, I updated this draft. including the following pass types have been updated, including the addressing modes, the unicast address mapping, the neighbor discovery, command frame header, and connectivity and topology. Okay, next page. So comments after IETF 98. So here I would like to thank Samitra and Gabriel for building the connection with ITUT Studio. And finally we got the support from Stefano and Sari. They are two PLC experts from ITUT, and they have reviewed our drafts and following on their comments. So here I will not go deeper into these comments, but I would like to mention that Stefano is the chair of SG15 Q15, which is a PLC study group in ITUT, and he suggested that they send the informal feedback at first, then exchange license to make it official. Okay, next page. So following the updates of this draft, first is the addressing modes. There are two kinds of addresses in PLC devices. The first is the 64-bit, the globally unique long address, and the other is the 16-bit short address. So in a PLC network, each device joins the network by using the long address and then communicates with other device by using the short address. Okay, next page. And for regarding the unicast address mapping, we use the 16-bit short address mode only. And for 101.2, since there is one line referring to the RFC 4944, so we put the 16-pan format for the short address here. And for the ITUT G.903, we put the pan ID in front of the short address. Okay, next page. And in this version, we updated a new subsection, namely the neighbor discovery. For the IEEE 101.2, there are two kinds of routing protocols. One is Ripple for layer 3, and the other is LoadNG for layer 2. So if the Ripple is used, then the neighbor discovery process refers to the 16-pan ND. And if a DHCP v6 is used to assign addresses, then the duplicate address detection should not be required. And if the 101.2 uses the coexistence mode with 9903, namely the LoadNG protocol is used, then the address registration defined in the 16-pan ND should not be used because there is already a defined pan bootstrapping protocol. But those mechanisms in 16-pan ND for managing the IPv6 prefix and corresponding header compression context information can be used. And again, in the ITUT 9903, since the LoadNG protocol is used and there is a predefined pan bootstrapping protocol, so we don't use the address registration defined in 16-pan ND. What's mentioned here is that the 9903 supports the 16-pan context option, so we specify that those mechanisms for managing the IPv6 prefix and corresponding header compression context information must be used. And moreover, for sending the ISRA, the PLC devices must follow the corresponding sections of the 16-pan ND. Okay, next page. For regarding the command frame header, this header was defined in 9903 mainly for the pan bootstrapping protocol and for the LoadNG protocol. So in our draft, we specified order in the header format. It should be put in the last position if more than one header is present, and it should be put before the 16-pan IPHC header. Based on Samita's comment, we updated our example in our draft. We put the command frame header in between the fragmentation header and the IPHC header. We use an ESC. Dispatch type to indicate there is another dispatch type follows, and this 1 byte is used for the command frame header to store the command ID, and then follows the command payload. Okay, next page. About connectivity and topology, still we have star, tree, and mesh, but in this version we clarify that they are logical connectivity, not physical links, because there is some confusion that if we consider the physical connectivity, the PLC devices are connected in a trunk link, but if we consider the transmission distance, then they are connected logically into star, tree, or mesh topology. And we did some name change in this section so that it can be consistent with 9903, which had the CO previously for coordinator to pan coordinator and the node to pan device. Okay, next page. Last time I put a question that if it is possible to include more PLC standards, and now the answer is yes. So currently we have 191.2 and 9903, and then more PLC standards like 1904 prime and 1901.1 can be considered. And well, the 1902 G.H and EM has been ruled out because currently there is no deployments. And about our next step, we would like to call for the working group adoption so that we can have a further discussion with ITUT and IEEE officially. And again, your comments and feedback are always welcome. Thank you.
Pascal Hubert, thanks a lot for this work. I mean, we had an early draft by Daniel Popa long ago, and that activity stopped, and that was a shame. So it's very good that you're taking this over, and I thank you for this. I'm curious. Initially, the first work I was aware of was for IEEE 1901.2,
yes,
which is the classical stack that we care for. IEEE, IETF, usual stuff. Now, I thought that the ITUT was designing its own stack. And what kills me, what bothers me, what I don't understand is if we do anything normative, which we feel is normative at the IETF for the stack over ITUT G9903, is it a norm to be, the standard to be used by ITU people? Who would want this specification, knowing that the ITU does its own? I mean, is it a competition to the piece that you're defining for the ITU network? Is it a competition to the stack that they built? I mean, how do you position your work versus their work? Did they ask you, or did they say, oh, I don't want to put the IETF in a weird position where we are defining a stack over something in replacement that they already have, right? Because they already have 6LoWPAN over G9903. That's why we gave them the escape byte, etc. So why should we be doing here for that? I mean, competition?
Well, here I would like to put, because currently there are many PLC devices, and for regarding the narrowband PLC, you will also have, let's say, the 101.2, the GC PLC prime, and 101.1. So currently for the vendors, it's very difficult to find a really good PLC standards for their use. So I would like to combine them together in a single draft. And if there is something in common, we can put it together. And that's.
But imagine you say you must use ND arrays to advertise this, right, in your document. But then the ITUT already defines a stack and they say how they do things. And now there is a collision there or something, right? How do we resolve that? And are we mandated for doing this work? I mean, is it something that the ITU, the chair of the ITUT 9903 has asked you to do? Thinks it's nice that the IETF does this? I'm just concerned that we may have an issue trying to define something for them. That's all. It's just a question. You don't have the answer.
Okay, so so they did not ask me to do anything, but when I send this draft to them and ask them for the review, and if you're very happy that they can find someone who are still promoting their standard, and actually they're still maintaining their the 903 and prime, but currently their focus is on the layer 1 and layer 2. And so now they have some guy to focus on the adaptation layer. It would be better.
Yeah, but to be clear, no, it was not them that asked us anything at all. It was more, this was brought here, and we were wondering whether there's other people in the world doing PLC. What do they think about this? Just like we asked of NFC, just like we asked of any other link layer. We want to make sure Bluetooth, etc. Want to make sure that we're not, conflicting with them. So we want to make sure there was no conflict. We got them involved. The ITUT looked at this. They're actually offered comments. But, we might want to clarify a bit further how they see it, because the comments have been fine, saying, hey, okay, this none of them has said, oh, please don't do it or we'll ignore it. There's just been helpful, constructive comments. But your point is about clarifying what is the function of this versus whatever else they may be doing there.
I mean, because maybe they would,
that's a fair point.
I can read a document from somewhere else, which is kind of informational and describing what we do. On the other hand, if somebody wants to normatize something we are doing here, I would not be so happy. So it's just, do they understand that we are doing a standard track document with a norm of how things should work on their network? Or do they think that we are just describing what they do? As an informational, that's a very different beast. So just, yes, sure, we clarify this, make sure there is no letter
sure,
collision.
Okay.
Yeah, and we definitely will do that. You did also mention something about liaison. Liaison has a very specific meaning in the IETF, and that might have come from them. They wanted an official liaison. There's some liaisons already from certain groups in ITUT. I don't think we want to go there for this because the way that it's going so far seems to be okay. The best way to collaborate is actually not through establishing all these big liaisons. That's for other types of interactions. But the best way is actually for the people to do what you're doing, exchanging information, comments, going back and forth. And so I think we should push forward with that. And hopefully we don't have to do a formal liaison, which would have to involve IAB because IAB handles liaison. So that's another process altogether.
Okay. Okay.
Yeah, I agree with Gabriel on the collaboration part with ITUT. So Pascal, we actually got positive comments from the PLC as the working group FG15 chairs. So yeah, we are with collaboration, and I think if there is anything new that are different from what they're working on over there, so that piece then should be communicated and agreed upon. Otherwise, I think it is as this is similar to any other documents we have, like with PTLE or NFC.
I mean, Samita, Pascal again, this is really where my confusion is. If this is an informational document saying what they do, then it's a separate document, just informational. If it's something that specifies new operation in a normative fashion.
Yeah, there is something new.
Right. And if we do that, then we need to make sure that they expect us to do something normative, not just like, for instance, in LP1, we have informational document about other technologies, but just descriptive.
Okay, point taken. Yeah, thanks. Yeah.
So Pascal, I didn't understand your point. Like, are they doing like L2 stuff or L3 stuff? Like, are you questioning if they're doing L3 stuff or not? They have? Okay. 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 If you can say that at the mic, yeah. Thanks.
My starting point is they came to us some time ago and asked for this escape field, meaning that they have defined the way they operate. So if this is a document which describes what they do, it's a different path. It's not a standard track, should not merge with the standard track piece for 91.2. It would be a separate document which would just be informational. Now, if we want to standardize IP operation over the network, knowing that they've already done some of that, I don't know to which extent, but they've done it, then we may be in competition. So if they are very clear that we are doing standard track documents here, I'm happy, If they think we are just doing informational, describing what they do, and all of a sudden they describe that, no, we are prescribing operations which are competitive with the one they did, then I'm sure they will be a lot less happy. But I mean, maybe it's all done. I was just asking.
Well, here in this draft, there is some content that refers to the annex part of 191.2, but I also made something based on my own, and hopefully I will contact the HOE side and make sure that they have no conflicts.
Okay. So just in the interest of time, I think we should continue on the mailing list. Definitely, I want to understand a bit better your concern, but I think we will resolve that offline, not in the next minutes or hours or whatever. So I think we can definitely move to after we resolve this point. If it's resolved favorably, we could think about a call for adoption in the working group. But we'd like to clarify that point first. Yeah. Thank you very much. So now we have body area networks. Sajad.
Hello, good afternoon.
Oh, sorry.
The first slide, sorry. So you can see this is the first draft, which belongs to wireless body area sensor networks, and we are looking to it with respect to IPv6, how we can make it the part of IoTs. So the current status is this is informational draft we just uploaded in the June, and we're looking for we will think about the standard track efforts, and suggestions and feedback are requested. Yes, next slide. So there are different motivations. I will just describe the few ones. Like one is like the population is increasing day by day. So this is the one of the survey, like 761 millions in 2025 people. They need healthcare. They need remote healthcare. Another motivation is regarding GDP. Like GDP on healthcare expenses are increasing. So on a report, you can see the different countries, they have different GDPs, but the alarming situation is like it's getting very high, especially with the USA. It is surveyed like it will approach up to 20% of GDP in 2022. So these are different indicators which we are looking, which are motivating for this document. The next slide. I will just introduce the wireless body area sensor network. With respect to IEEE 802.15.6 standard, which is active standard now, and it is standardized in 2012. It is, as all of you know, it based on MAC and file layer. The main thing is like it incorporates the better penetration through the human tissue without creating any damage to the human tissue. And it follows the approved mix band, which is medical implant communication service band by USA. So it's following the specific absorption rate guidelines, which is useful for human tissues. Next slides. So here you can see the different applications, different use cases for wireless body area sensor networks. A patient can be equipped with different sensors. This standard is specific with the implantable sensors, like when you implanted the sensors inside the body. And there are different use cases. You can use it for patient care. You can use it for elderly care center. You can use for the fitness and fitness for the sports. Yes, the next slide. The scope, like it defined the scope. It is basically a short and low power standard, like range is mentioned from 2 to 5 meters, and it wants to work on very low power. It is using ISM bands, and there are different bands. Very low frequencies band are mentioned. I will show you in the next slide. Yeah, it complies. Yeah, complies with strict non-interference guidelines. It is taking different guidelines with respect to medical applications as well. Yes, next slide. So why would you need to standardize this sort of application with IETF? Like there are a lot of proprietary solutions which are available, which are doing this stuff. So we just want to make it the part of standard, so it can be used by everybody. There should be a standard, like there should be a standard body. So current solution are optimized for different type of applications. Beside medical, like Bluetooth is optimized for voice links. Zigbee is optimized for the sensor, industrial sensor applications. Wi-Fi is optimized for data networks. So these are the general focus points which they are doing. Is the next slide. This is just a comparison slide between different existing standards and 802.15.6. You can see it want to work on very low power, like 1 milliwatt or less than 1 milliwatt, and you can also get the high throughput, like you can use ultra wideband in this standard, but still they are following the human tissues guidelines. So you can see it is low power, and in data rate you can achieve different data rate. The purpose of the high data rate, it like there is diversity of the different medical sensors. Like if you are using ECG, so it's contain different sort of cables, so you need high throughput. So that's why the throughput, the data rates, it varies in this standard. The next slide, please. These are the different frequency bands. It's mentioned. You can see the human body communication there for different frequency band. It has different. It has 3 types of file layer, like narrowband, ultra wideband, and human body communication. This is the specialty of this standard. Next. Yeah, it's channel access mechanism. It's a little bit different. Like although it work on the same pattern, like 15.4 is working on the super frame. Like channel is divided in the super frame, but for the medical application, they have mentioned like different phases, like EAP, like emergency access phase. You can see the different EAP in a single super frame. Then the random access period, and you can also see the content access contingent access phase like CAP, which is also available in 15.4. So it's little bit different from 15.4. Yes, next slide, please. So you can there are obviously benefit for if we use it with IPv6, like we have the addressing flexibilities, and we have auto configuration solutions available. Simple, like if you are connected with IPv6, so it means you are part of internet, like you can be a part of IoTs as well. So that's why we are looking for IPv6. There, next slide, please. So there are different issues, like, but specifically we are mentioned like the packet size, like frame size. It's in the standard frame. The frame size is 256, which is different from 15.4, which like it's 127 bytes. So this is a few issues we need to look if we want to make it a standard track, like how we will deal, like are we going to adopt 6LoWPAN, or we are going to look to the compression mechanisms, how IPv6 deal with it. So yes, the next slide. Yeah, there are different industrial, you can see different industries which are adopting and making the chips for 15.6 Texas Instrument, National Instrument, analog devices. So the work started. So
I'm in line.
Oh, you are. Good.
the next, yes, because so this is the brief introduction for the document, as it's our first document. So it's still informational. We're looking forward.
So Suresh Krishnan, Noah Hat, I read the draft and there's really nothing in there about transmission of IPv6 frames, right? Usually when you do IPv6 over full, it's like a set of things you specify, you know, the unique address mapping, multicast address mapping. This one only has informational text about body area networks and nothing else. So is that the intent of the draft, or like what are you intending to do?
No, like because because it's just uploaded in the June, and we just want to clarify the need. Like that's why we mentioned the word wireless body area sensor network as a focus point. But you're right. Like we should also mention about the IPv6 sort of things, how it can be incorporated. Like we have discussed in the group, but we didn't mention in the draft.
Okay, no, but all it says is like, oh, 6LoWPAN does not work on this, right? It says the frame format is different, 6LoWPAN does not work, right? And that's it. So because like the title is kind of misleading. It says like transmission of da 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 or something has to specify all this, right? And that's why if you're talking about the need for using doing 6LoWPAN for this, then it's different than saying it's transmission over, right? So
like our focus is on like to use for this standard for the medical application. So
that's okay.
Yeah, and in the second step, yes, you're right. We need to look in detail how we will manage it with IPv6 and those sort of thing, and we're working on it. But we thought like after meeting we will update the draft to comment.
Just to, from a chair point of view, there's nothing in here for the working group to do. So this would not ever become a working group document because there's nothing for us to do. So it was a good informational presentation, but
yeah, for the timing it's informational document, but
yeah.
we will look for the response and the feedback if we get, so we'll think about this.
Well, yeah. So for next time, think if there's something for us to do, then yeah, we should work, think about that. But if there isn't, then that's fine.
That, Pascal, that pretty much echoes what my questions were. I mean, do you expect, what do you want to build on that? I mean, do you want to build a mesh? Do you want to, I see that there is need for reliability. Would you like us to put 6 on that file as opposed to the classical 15.4? Would that fit the kind of application that you have in mind? We need to know the applications. I mean, I really can figure out a mesh of that on my body. I think the idea is quite cool. But I don't know what I would put on it. Oh, that's another question.
Yeah, 6 can be a good option. Like
exactly. Well, if you were to describe this, and mostly, you know, I want to do a mesh, 6 mesh on it. So here is what's missing from 6 to get this mesh on my body. Then we could act on it, right? That's pretty much.
I will again mention, like, the purpose of this initial document is to highlight the importance of this standard, like, which is not the part of this. So like, we highlight the standard, and now we are looking for the solutions.
Okay.
Yeah.
Alex,
So,
and then we close the mic on this one.
Okay, yeah, thank you. So this is Alexandre Petrescu. I work at CEA in France. I looked at the draft, a very nice draft.
Thank you. You're the
I
first.
see a frame format section. There are about 300 bytes in this frame. Is this the maximum transmission unit?
256, yeah. Exactly.
256?
Yeah.
So the MTU on wireless band is 256?
Yes.
I think this is a good starting point.
Yeah, that's why I mentioned in the last slide that, like, the issue, like, we need to think about this.
Okay.
We need feedback so we can give space to this standard, which is important for healthcare application and healthcare system.
Yeah.
Thank you.
Thank you.
Thank
you. Now we get to the final part of the meeting, which is going to be on fragments. Pascal?
Okay, so this is a discussion that we spent a bit of time last IETF. I exposed a number of drawbacks of the current fragmentation as disclosed in RFC 4944, which are mostly problems in the route over world, and unless we get clear signals from the mesh underworld, maybe the mesh under lives perfectly happy with 4944, but that creates a number of situations in route over that could be improved. So I won't redo the slides I did last time. I left them in the slide were in appendix. So if you download the slides from the website, you'll find that after the apparent end of it, you'll have all the slides of last time. But I will basically use your knowledge of what you said last time to basically look at what the problems are and what we need to solve. Right? Please, next slide. So then again, presented that last time. And yes, there is another aspect which needs to account for, is that for the LP1 work, we have also started working on fragmentation, and we have been thinking of a number of solution space things which could more or less apply to the work here. So like windowing and individual retry of fragments. So obviously the use case is quite different, the solution will be different, but we may take inspiration from the work that's been done there. A bit of concept for fragmentation. So initially, the first, very long ago, first 6LoW networks, there was some TCP, and the reason why there was some TCP is just because of this problem with fragmentation. So people would rely on TCP because they would get MSS, max segment size. Now, the drawback of TCP, obviously, mostly if you send very small chunks of data, is you have to pay the price of an acknowledgement back every time, and that's really too costly. So the industry moved to UDP, CoAP, etc., which gives the application the capability to request an ACK really when they want it, and usually they provide the ACK is not is an app level ACK with some semantics which come back, not just hey, I got you, but I got you, so here is what you should do with it. So we're in a space where the acknowledgement is also mostly loaded with application space information. And on the side of your brain, remember that we talked a lot of streamlining last time, explaining that the packet could actually be reassembled at the other end much faster if we can streamline fragments as opposed to recompose at every hop. And actually, this gives us time that we can use for retries. Just a rule of thumb is the application is not changed if we can live within the time that we gain by streamlining. for doing our retries. Okay, next slide, please. So the summary of the prime that we discussed last time, prime 1, unless we do something which is not documented in any standard, we need to recompose the packet at every hop because we need to build the IP packet so as to route it and then pass it to the next hop. So we need to fragment, pass to the next hop, recompose, fragment, pass to the next hop, recompose, and that's what creates this very huge latency and buffer bloat in the intermediate nodes. So we basically want to be able to forward all the way. There is no control at all, nothing which tells you how to pace your fragments, how to slow down, how many fragments can stay in the air. So implementations tend to push all the fragments as fast as they can, and there is all sort of interference and buffer bloat which can be created inside the network again. Not only that, but if you have multiple flows which cross on the same router, then it will have to store buffers for all those fragments at the same time, and we end up with the classical congestion loss that we see in switch fabrics. But with the number of buffers that we have there, that gives us loss very rapidly, and losing a fragment has the side effect that we know that the endpoint will be waiting forever to get the fragment it's waiting for. Which is my last point. If you have some loss, then the recovery side, the assembly side, will have to time out. And actually, that's experiencing this, which led this RFC 7388 about which now helps us debug network. That's because they did this as an MP thing that they found that the problem they had was fragment loss. Question, David? I'm moving to the next slide.
I suspect I'm about to reveal that I know next to nothing about 6LoW. What exactly?
Name, please,
sorry, David Black, TSVWG working chair, trying to understand what's going on here. So, what exactly are you trying to do with that first bullet?
Okay, so I mean that's when I'm skipping what I said at the previous meeting. I'm very sorry for this, but you get this mesh of 6LoWPAN devices, and you're doing ripple routing over it. And now you're the 6LoWPAN, the classical 822.15.4 network, the PHY, will have 128 bytes of MTU, which means that if you want to provide the expected service of 1280 for IPv6, you will have to fragment anything which is in the order of 100 bytes and above.
Right,
Sorry?
L2, okay, yeah. Somebody's repeating what's in the audience. L2 fragment, that's really important. So what's happening is the transmitter has done an L2 fragment, and now it says at every L3 hop. So what do you want to do with the router?
It's not, okay, it's not an L2 fragment, it's a shim. So you've got this IP, you've got IP which sees 1280. Then you've got 6LoWPAN, which cuts it into a number of 6LoWPAN fragments, right? Mm-hmm. And this thing will do multi-hop over the Ripple network. Now, if you
as long as you're at L2, nothing's gone wrong because I go hop by hop over L2. I hit the next. I hit the far end of the link according to IP, and at that point I need to pack it back. Which is the next hop
because that's what we call route over, right? Every radio hop is a router.
Oh boy.
Okay. Now, do I need more, or is it okay?
No, that's what I'm afraid you're doing. Okay, what? Let me let you finish your presentation, but oh boy.
Right. And so,
just to clarify, there's route over and there's mesh under. When this was written, it was for mesh under, in which you recompose at the very far end. For route over, there's all these problems.
For route over, you put the packet at every hop all the way to IP layer, and you need the full packet there to route it to the next hop.
Yeah, right. And the reason I said oh boy is for what Gabriel just described as route over. You're effectively asking a router to route and forward an L3 packet, an IP packet that it hasn't actually received. It's got the header and
exactly. That's what we're after.
Yeah. Okay.
So
like I said, oh boy.
Yeah, customer on broken record mode. Broken record mode. What's written there in the first? Hello. What's written there in the first bullet has been possible for about 10 years now.
which is what you're afraid of, David. It's been possible, it's not been described, and people...
It has been described.
I've
Next.
read your book, and it was missing the... Well, we can discuss that offline, but you don't indicate that you need to swap
Now,
labels.
there is a difference between an implementation technique and a normative document that defines a protocol. There is an implementation technique that avoids point 1.
Yes.
Okay. Now, of course, we still have to work with those other points. So, for instance, we have to think about what does it actually mean for the first fragment to be sent, the next router actually forwarding that first fragment, and at exactly the same time, the original sender sending the second fragment.
Yeah,
So
but I disagree with your first point that we have done everything, that there is nothing to do for the first, right? I can do you want to keep that, my answer for later? The point is, I agree that it's mostly a local behavior that doesn't need a standard, it needs to be done well, but it's about creating a state for the next fragments. And so what requires a protocol is, when do you know that you can clean that state?
Yes.
Right, and
So
this boils down to, well, to the last point about fragment recovery. If you have a fragment recovery, then you can use that piece to clean the state, and that's when there is a relation. That's my answer to you.
Okay, so there is a number of implementation issues about timing here.
Yes,
and
a number
it
of them.
probably would be a good thing to think about those. And if I hear what you just said, you want to conflate them with retransmission.
I want to well, no, not really. The 2 points in the middle are really close to one another. What is conflated is the recovery and the solution to the recomposition, because you can use the message back, which enable recovery, to also signal, I'm done. I got them all. You can clean the states in the middle.
Well,
That's the only conflation I have in mind.
Important observation is that this message back already has been there for a long time. So we do radio layer X of all of our packets, of all of our adaptation layer packets, except for multicasts, including fragments. So that has already been there. So you are asking for a different kind of additional retransmission.
It's the, okay, 6-loop and wide end-to-end. It's not the one hop thing.
Right.
It's a multi-hop thing. It needs to be very, very clear. Right. Yes.
Yeah,
true.
and
That's why it's a route over program, right? Yeah.
And I'm going to say the next thing when you're at the slide that.
And yes, exactly. And that would be next slide exactly. So let's keep that for next slide.
Spencer Dawkins, just as a nosy individual, just to help me understand, because I haven't read any more of this draft than David has. Are we talking about many, I mean, like most packets being fragmented, or is this a relatively small number?
There are 4 use cases in the IoT mostly. 2 of them, once in each direction, requires fragmentation. One is reflashing of devices, quite rare, and so that's going down to the devices. And the other one is, there are some examples of IoT devices which will capture a lot of data in one bulk, like vibration, store that in a file, and then you need to stream that file all the way up. And you want to do that some blocks. Most of the normal IoT activity will never fragment. Good thing.
So, and the last question, just to help me keep up. So if you do have a loss, are you, today, if you do have a loss, are you retransmitting the whole packet or just a fragment?
The whole packet. Yeah, it will be
Okay, yeah,
transport layer retransmission.
so what I would expect.
Yes.
Okay, cool.
And it's not even that. It's today's cost of energy associated to that and a lot of latency, because those timers, those retry timers, are infinitely long, because this network is so slow and it can be very variable as well. So the timeout values are very huge. But the other drawback is mostly what touches us at the 6-loop layer is the devices are usually constrained. Right? Mostly,
Sure,
for instance, if you're sending a new image to this IoT device and you're losing just one fragment, the timeout is actually very long. And usually all the buffers are clogged with things like that, and now you can't receive anything. And that's really what created this RFC 673.88, because he was wondering, Jorgen was wondering why he had so poor performance on his 6-LoWPAN network. And the reason was, once in a while there's a packet being fragmented, the loss ratio being what it is, he would consume all his buffers, and then he would drop the other packets, you see. And and he could debug that because he introduced SNMP in that device, and that's this RFC.
Cool, thank you.
Ouch. Yeah. We could
to
see it
correct
coming, though. We saw it coming.
One thing, of course, there is a retransmission per fragment, which is based on the radio layer egg.
On the one hop.
Yes.
All right. So we cover one hop. We don't cover the mesh. I hope I wrote it in the first slide. Otherwise, I hope it's very clear on the document. Now, if you progress a little bit on the network and you don't have a NAC back, or I don't know what, then if the packet gets lost in the middle of the network, you're screwed. If it's after you retry, you can still progress. You're not screwed.
Rahul Jadhav from Huawei. So I think it's an important problem to solve. The problem statement is important, but I have some reservations towards the solution.
We're not here for the solution, but I would take them on the mailing list.
So one of the primary disadvantage Carsten already highlighted about the sender and receiver both forwarding at the same time. So while the first fragment has been sent from the receiver towards the next hop, so it increases the collision rate.
You mean the acknowledgements back, or the second fragment?
No. So the sender is sending a first fragment, then receiver receives it and then sends it forward. But by the time the sender has another,
the sender is the relay, right?
Yeah.
That's what you mean, the receiver.
So this was not the problem currently.
It's one of these. It's actually fragment flows interfere
with one another. Yeah. So.
6-stage I won't have any problem like that, because the second half we use.
Oh yeah. So for 6-stage it won't be a problem.
That's why I specify single frequency mesh, which is usually Wi-Fi.
Yeah. So the other problem that I see is with regards to single buffer strategy. If any of the device in the the path has a single buffer,
okay,
or let's say the sender has a single buffer, then unless and until the complete all the fragments are being received by the end receiver, it has to wait.
Yes.
And that will take substantial long time as compared to the
solution
L3.
is not mandating anything about not buffers, right? I mean, so it's not prime against solution, it's a prime, right?
No, I'm just saying that, there's a scenario where the sender has only a single buffer. Let's say it's a constraint node.
Oh yeah, that's really what caused prime in our system.
Right.
Yeah.
So let's say it has 10 fragments to forward. And now, in the current case, it forwards all the 10 fragments in a single stage.
Oh, without any wait. Yes, it pushes them.
There will be layer 2 acknowledgements. There will be all. So, but the point is, now it has to forward it 5 hops down the line.
Oh, it will take more time if you slow them down at the source. Yes.
And you won't be. So the source has to now keep a bigger queue for all the other packets which are buffering over the time.
True.
That's true, right?
Yeah.
So I just want to take into consideration this.
Just high order a bit here. I'm going to cut the line right now. So after Thomas, because we need some time at the end. We want to actually ask some questions. This is not about designing a solution. This is not about a solution. This is just about here's some potential issues, and then the questions will be more like, should we do something about it? That sort of thing, right? So we want to get a sense of the room of whether we should do something about this problem.
I'll be very quick, Thomas. I think this is an important issue that we need to address. It's a major pain to have to reassemble at every hop. It's all kinds of problems with buffers, how long do I wait, stuff like this. And I've read your draft right before the meeting. I've sent a kind of a very detailed PDF with many points. If Carsten says it has been done, great, but I'd like to understand how. Either we can have a side meeting. I mean, we need to do something about this. I think we agree it's important. This has been coming up so many times. I'm waiting for something I can use. And so either we come together this week and we figure it out, or I don't know, we do an interim, but I mean, this cannot be coming up again in Singapore and again after that. We just have to solve this thing. It's not hard.
Can we move to the next slide, and then we'll have a lot of time for question and response? So based on the primes that were listed on the previous slide, I basically made that list. Don't know if it's complete, but it's my view of it. First thing, we need to provide fragment forwarding. So whether it's a secret sauce in a node, or we actually explain, there are pitfalls. I described them last time. There are ways of doing this very wrong, which appear to work until they don't. So those pitfalls are known, some of them at least. I documented them in the slides. I'd rather propose a way that everybody understands, that everybody validates, that does the fragment forwarding well. Okay, even if people have been doing that for 10 years in their own implementation, I'd like the IETF to come up and say, here is a way that we recognize work, and we'll do the trick for you. And yes, my draft says you can do it with MPLS switching of the label, of the data contact. Point is, if you fragment the first packet if you forward the first packet with the IP address, then you need to leave a state for the next fragment that you need to clean later. Second thing, we may or may not want to solve the second prime in the previous list, which was kind of this burst of fragments going on. If we send this burst, like Raoul just said, we free memory on the sender, but we bloat the next hop, and then the next hop, which may get different bursts coming from different places. At the end of the day, packet loss, fragment loss, all the bad things. Do we want to do some pacing windowing to avoid loading the network beyond its capacity to avoid congestion loss? Same thing for, next step, sorry, fragment reliability. Do we want to be able to retry individually fragments which have been lost somewhere in the middle of this mesh, right? So exhausted retries in the middle of the mesh, what do we do? And last but not least, ECN. Do we want to be able to throttle more or less efficiently based on the current state of the network? Do we want to provide some form of explicit congestion notification? So my session draft obviously has them all, but clearly also people might think it's a huge overkill. So that's where the discussion lies, and then maybe other solutions in mind. But at least my draft says all this can be done. There is a way to do it. Next slide. So I just said the first line. This is a fast forward. Like Thomas said, we've been there for so much time. I mean, this problem has been there. It hurts.
This is part of the questions that we can ask.
Okay, okay, so I'm done.
Okay.
In the appendix, you'll find my slides for last time with some drawings and stuff, David, if you want to go through them.
Samita, want to drive?
Okay. I can go through some part of the slides and let's see how we can handle the questions. So thank you, Pascal, for elaborating the issues with the route over. So when RFC 4944 was defined, IPv6 for 802.15.14, 802.15.4, it was mainly designed for mesh under forwarding. This is mostly at the 2.5 layer, packet forwarding with the 6LoWPAN adaptation layer and mesh header. The problems that if you want to use the same technique for route over, you will have the problems that Pascal already mentioned. So the next few slides, we are going to, Gabriel and I, going to put together some of the questions and see what should be in scope and what shouldn't be in scope. So we know that we have solved mesh under, but we want to ask the working group if the current definition for fragmentation, forwarding, fragmentation format under mesh under is sufficient for other 6LoW technologies. If there is any interest in the working group to revisit and reevaluate that. Partly, I know that some of the other technologies that we have specified in this group, many of them don't want to use fragmentation because because of their MPU size, or that's what they have specified. And if there is any implementation in layer 2 that they may want to use mesh under with fragmentation, that is something then we can work on it. And the second question is route over. It looks like Pascal has been promoting the fragmentation solution for some time, and today in the working group we want to, I think, take a consensus whether we are going to work on this route over fragmentation solution, knowing that the current specification is not sufficient. So, Gabriel, do you want to take the consensus now?
We have 5 minutes left, so I think we should get onto the questions. So,
okay.
Carson, do you have a clarification question or something very quick? So I want to go
just want to make sure that we actually discuss things that exist. So, no, actually, the solution in 4944 works for route over. So
okay, so let me ask the questions then. For first, we'll ask a question about mesh under. How many people here think that 4944 and the collection of associated documents, basically the 6-low model, is fine for mesh under work for other than 15.4, or maybe even for 15.4? Basically, do we need to do something extra for, in particular for mesh under? Is anybody interested in that? Things that it's needed. Okay, so I see nobody raising their hand. For route over, how many people in the audience think that the working group should do something, or the IETF, whatever, maybe it ends up somewhere else, that the IETF should do something about improving fragmentation issues for route over? Raise your hand, please. Okay. Let me count a second.
I'll say about 20.
Yeah, it's 20 plus. So it's about probably more than half. Okay, so that sounds like a definite.
What's the number? 20?
It was more than 20, 21, 22-ish. It definitely looks like more than half of the people in here right now. Yeah, we will. Yeah, both of these questions we will report what we saw here, but we will confirm on the list. So if you didn't get a chance to raise your hand here, you can do that on the list. Well, the big question with the 3 seconds that we have right now is, it seems reasonable to think that there's going to be potentially some work on route over. Carsten disagrees with that.
No, I'm not disagreeing with it. We need to properly describe what we are doing.
Yeah, that would be part of what we would do. Okay. And then I, actually do it. So what do you mean by that? You mean
there are 3 parts that are muddled together here. One is describe what people have been doing for a decade. That's probably a good thing to just write it up.
That may be a good thing, but I think this exercise is not about an informational document.
No,
so
but one
that's a great thing to do. That go into an article.
Requirement to get out of this muddled thinking. The second one is, do we have recommendations for implementations to do good timing in the presence of these optimizations? It's probably also informational, because it just describes good practice how to do things. But it could also be normative. I don't know. And the third one is, do we want to add a completely new thing, which is the fragment retransmission mechanism that goes over multiple hops within the 6-low pen? That's a completely new thing, and one where we maybe getting some transport pushed back before we have described exactly what we want to do.
Yeah, I also saw
But the first
other new things like ECN. So there's different potential new things that, and I guess that's the last question, a design team should go off and figure out. And then for each one of those new things, say, yeah, we think we should do it, and here's how. I don't think, I mean, it would be great to have some background info, but the main output of this effort, I think here, from the point of view of working group, is if there's something to be done, what is it? What's the normative text that we're going to add into the collection of 6LOC documents? You know, and history is great, and we can use it, and maybe we can even reuse it as is. That would be great. We just need to solve the problem or problems. So I think a lot of the questions you're asking are right, but that might be better for the design team to go after each one of those, and that's something we have to continue. Definitely, we have to continue. So, final question I want to ask is how many people here would be interested in forming a design team to work on this specifically? Let's see. The other thing I have is the people who are raising their hands, please send email to the chairs so that we have the composition of that design team. And that way we can say we can finish on time.
So the one thing that I would like that design team to do first is collect the research that we have available to actually do anything.
That would be a good input to the design team, but there
Yes.
may be other opinions. But definitely, I think we have to close at this moment. We're officially at 1 minute over, and there's a social, and people have to go grab it. So at this point, we will confirm these things in the mailing list, but we're done. Do I have both blue sheets right here? Is there another blue sheet in the room somewhere?
Thank you, guys.
Yeah. Yeah, that's good. Thank you. Thank you.
Huh?